All right, here we go. So our goals are we're going to be interpreting descriptions and graph of functions. Okay, based on my last period, y'all did talk about functions last year. So we're going to be looking at functions. We're going to understand that a relationship between two quantities is a function if there is only one possible output for each input, and we're going to talk about what that means. We're going to use words and graphs to represent functions. So we're going to see how it's represented in words and also what it looks like graph. And then we're going to identify what the independent and dependent variables are in a function and in a graph. So a lot of these concepts you've talked about before, but we're going to just kind of add them into this deeper understanding for algebra. So this first section right here, and if you didn't get that, I hate to be that person, but like I will be checking your books when we get back to school, like I did for the homecoming video. So y'all know how much you hated going back and watching those videos. So this should be an easy grade for you, just copying down these notes. So I want you to imagine yourself in a bagel shop. Okay, so remember we're talking about functions. That's our focus. Okay, so we're in a bagel shop, and you see the menu up there. We have one bagel is $1.25. 6 bagels is $6. 9 bagels is $8, and 12 bagels is $10. Okay, so there's all the prices that we know. Okay, so based on that information, a customer at a bagel shop is buying 13 bagels. The shopkeeper says that's going to be $16.25 for 13 bagels. Okay, so I want you to look at all those prices and think about, okay, so somehow he came up with 16. How did he do that? All right, but then you're thinking, okay, you, Priya, and Han, Jada, Priya, and Han, who are in the shop, all think it is a mistake. Jada says to her friends, shouldn't the total be $13.25? Priya says, I think it should be $13. And Han says, no, I think it should be $11.25. So it wants you to explain how the shopkeeper, Jada, Priya, and Han could all be right. Okay, so each one of these prices could be correct. None of them are wrong, is what I'm trying to say. So what I want you to do is I want you to spend a second and I want you to try to come up with how did the storekeeper come up with that price? How did Jada come up with that price? How did Priya and Han come up with their prices based off of these prices up here on the menu? Okay, so I want you to do that. But before you write it down on your paper, I want you to send it to me in the chat so that I can see your answer. Okay, and then we can discuss it. Now remember, the more that y'all talk about it, the more I can, the quicker we'll get through it. So would y'all like for me to go over one with y'all first, or do y'all think y'all understand it?
Go over one. Oh. Yeah, actually.
Okay. All right, so the first one, and y'all do need to be writing all this down. Okay, so good question, Raven. We're not considering taxes. We're not considering other things that they paid for in the bagel shop, like drinks or whatever else. Like they're just buying the 13. They're just buying the 13 bagels. We're not considering the tax. Good question. Okay, so write down the storekeeper. All right, so the storekeeper said it was going to be $16.25. Okay, so how did he come up with this price? So I'm looking back up here at the menu and I see, I'm looking at all the prices, kind of trying to figure it out. Okay, well, there's 10, there's 6, that's 16. Okay, but nothing really equals 25, so that's not it. There's 6 and 8, that's 14 plus $1.25. Okay, that's 15. That doesn't work. So how did he get $16.25? Well, I see that one bagel costs $1.25. And we're going to multiply that by 13 bagels because that's how many we ordered. And since I don't have my calculator on my computer working anymore, I know if I use my calculator on my phone, if I do 125 times 13, that's going to give me $16.25. Okay, so he used the price of one bagel and multiplied it by 13 and got his price. So is that technically correct? Yes. Okay, so now I want y'all to do the same thing for Jada, Priya, and Han. Y'all don't have to go in order, but when you figure out how they figured out their prices, send it to me in the group chat and I can tell you, I can share your answer with everyone else. Okay, so it'll go based on how quickly y'all figure those out. So let me see what you get. Make sure y'all send y'all's thoughts in the group chat.
Is Easton here?
No.
Yeah.
All right, so Raven got Priya's. I thought that was the hardest one to figure out, but that was the hardest one for me to figure out anyways. So Raven saw that the price of 9 bagels was $8. Okay, so we have $8. And that's going to give us 9 bagels. Okay, but we still have 4 bagels that we haven't accounted for. So that's going to give us, we're going to do the price of 1 bagel. And we're going to multiply that by 4. And that's going to give us Priya's price, which is $13. Good. Okay. So, and then good, Raven. Raven also got Hans, which Han said the price was $11.25. So Han did the price of Han did the price of 12 bagels for $10. So that's going to get us 12. Okay, we still need 1 more bagel, so we're going to add on the price of 1 bagel. And that's going to give us the $11.25. All right, and what about Jada? Can anyone figure out Jada's? It was $13.25. How did she get that price? All right, so for Jada, she saw that 6 bagels were $6. Okay, so she took the price of 6 bagels plus 6 more bagels. So that's 12 bagels total. So she's going to add the price of 1 more bagel. And that gives us the $13.25 for Jada. All right, so keep in mind, all of these different prices is for 13 bagels, right? Do y'all agree with that?
Yes.
Yes.
Okay, so we know that if we go to like a place that has bagels, I don't know, Starbucks has bagels. So we want to know that every time we go in there, when we buy 13 bagels, we're going to be paying the same exact price every time. We don't want to go in there sometimes and spend $16 for 13 bagels, or go in there another time and spend $11 on bagels. We want to consistently pay the same price. Okay, so that brings us to this table over here. Okay, the number of bagels is going to be our X value. All right, and then our Y value, we're going to go with the price of the bagels. Okay, so it says your teacher will give you instructions for completing the table. Okay, so that's what we're doing. All right, so what we just discussed is that based off of this information that we said could all be right, we have four different prices that 13 bagels could be, right?
Yes.
Yes.
So write all those down. All right, I want you to take a second and I want you to try to figure out what all the other prices could be based on the information you had. Okay, you can use whichever method you want to fill that in, and then we're going to talk about it. Okay, I'm going to give you about a minute. You may not finish the whole table, but I want you to attempt to. All right, ready? Okay, let's look at it. So, what did you all get as the price of one bagel?
$1.25.
$1.25, okay? Most of y'all probably got that same thing, okay? So if one bagel costs $1.25, how much is two bagels going to cost?
$3.
No, not $3. One bagel's $1.25, so two bagels would be what?
$2 and some cents. 30. No, never mind. I can't do math right now.
$2.50. Okay, you're gonna just add $1.25 to it. Okay, so we're gonna do that again. So how much would three bagels cost? Did anybody do this during the time that you were supposed to?
Yes, my bad. I think I added the wrong one, so I'm going back and doing that.
$3.75. Okay, then it would be $5. Then it would be $6.25. All right, if we continue doing it that way, then it could be $7.50. But what do we also know? Over here,
$6.
six bagels is how much?
$6.
$6. So this one could be two different prices, okay? So if we continued this way right here where we're adding $1.25, how much would it be? $8.75. But if we go based off of the $6, how much would it be? $7.25. Okay. All right. Then how much would the $8 ones be?
$10.
$10. All right. But if we started over at 6, how much would they be? $8.50. All right. Then here it would be $11. Nope. $11.25. I'm sorry. All right. But if we had started over at 6, how much would it cost? from this column right here, sorry. 975. All right, but what do we know from our table?
9
10
bagels
bagels.
is $8.
9 bagels is $8.
Was $8. Okay, so far for this one, we have 2 different prices $6 could be. We have 3 different prices that 9 bagels could be. All right, so let's continue. If we would have continued with these pricings right here, this one would have been $12.50. This one would have been $11. And then this one would be $9.25, right?
Yes, ma'am.
Yes, ma'am.
Because all I'm doing is I'm increasing them by $1.25 based off of this new place we're starting. All right, so how much would $11, or I'm sorry, 11 bagels cost?
$13.75.
$13.75. But what if we went by these orange prices?
12.
$12.25. What about the green prices?
$10.50.
All right, and then finally we have 12 bagels. How much would 12 bagels cost?
12 bagels.
Yep, based on this first one. $15. $13.50.
$12.
And $11.75.
There you go.
All right, so there's a lot of different ways you probably could have filled in this table. So I'm going to show you this really nice organized version of it. So we have this right here. We have the number of bagels as our X, and we have the storekeeper's price, Jada's price, Priya's price, and Hans. All right, those are all of the same values that we just came up with. Okay, the storekeepers was where we started at 1. And we increased everything by $1.25 each time. Jada's was where we started at 6. And then from there, we added $1.25 each time. Priya's was where we started at 8. And we added $1.25 each time. And then Hans was where we started at 10. And then we added $1.25. Oops. Okay. So once again, I want you to think about these as functions. Okay. So based on off of our goals that we wrote earlier, it says understand that a relationship between 2 quantities. Why are you not seeing the same thing as me? It says understand that a relationship between 2 quantities is a function if there is only one possible output for each input. Okay, so what you have to know is that when you're looking at these tables, your X value is going to be your input. And then we have multiple for this. We have, these are our Y values are going to be our output. So if we're looking at this one right here for all the different prices, is there only one input for every output?
No.
No, there's not. Right here, starting at 6, we can see that there's 2 prices there. There's 2 prices for 7. There's 2 prices for 8. There's 3 prices, 9, 10, 11. And then there's 4 prices for 12 and 13. So since that true, is this first table right here, is it a function?
No.
It's not. And why is it not a function?
Because it has more than one possible.
It has more than one output for every one input. And that's what y'all did talk about that last year. All right, so now I want you to look at this table here. What's the difference in this new table that we have right here?
They both
It's
each
the-
have like one individual prize.
Each number of bagels only has one possible price that it could be. What's the difference in like how they labeled the table? This time, what did they do?
They gave you the best price instead of all the prices.
They gave us the best price. So if we went back to this one, for 1 through 5, that's all the same. But then when they got to 6, they chose which the best price was. When they got to 7, they chose the best price. 8, the best. 9, the best. And that's what they ended up with in the table. Okay, now looking at this table, would it be considered a function?
Yes.
Yes.
Yes, because now each output has only one input. None of them match. None of them have the same numbers. So like over here, let me find one. We'll look at it in the graph. Okay, so that's how you can tell with a table. That's just like your basic understanding of a function, is that if it just goes down to the very definition of what a function is. Every output only has one input. Okay, so we can see within this table that this first one has multiple prices for it, for the number of bagels, has multiple outputs for every input. Whereas this other one only has one output for every input. So let's look at this one graphically. Okay, so this matches our first table. You can see all the blue dots represent the storekeeper's prices. The green ones are Jada's. The red ones are Priya's, and the little triangles are Han's. Okay, so y'all may have learned this last year. I don't know. Did y'all talk about the vertical line test?
No, ma'am. I don't think.
Okay. Okay, so anytime you have a graph, I don't know why this is doing this. Anytime you have a graph and you want to know if it's a function, you can always do the vertical line test, which I would just use your pencil. Okay, so you'd take your pencil and you would start at the front of the graph and you would run it across the graph. And if at any point 2 of the dots on your graph are touching your line at the same time, then it would not be a function. So right there at 6 bagels, and my line won't get right perfectly on it. Oops. Yeah, it won't get perfectly on it because my computer's just being difficult today. But if at any point you have like 2 points that are right on top of each other like this, or like that, or that, or that, or that, or that, or that, or that, there's a lot of reasons this one is not a function, because at those points when your line got to them, both of those or all of those points would be touching your line at the same time. Therefore, it has failed the vertical line test. And if it fails the vertical line test, it is not a function. Okay, just like we said, that's not a function. And these graphs and stuff are not in your book. These are just graphs that I have that represent that data. Okay, so now, okay, so that's just the number of bagels and their price in dollars. So let's go to this one over here. I don't know why my technology is being difficult. Okay, so now we're looking at the one for the number of bagels and the best price, which we have already determined is a function, but let's see it pass our vertical line test. Oh, okay, that works. So let's take our vertical line gosh. Let's take our vertical line. Oh my gosh. And run it across. So far, so good. None of the points or multiple points are not touching my line at the same time. So is this one a function?
Yes.
Yes, it is a
Yes.
function. Why? Because it passes the vertical line test. Yay, that's how you can tell graphically. Okay, so we can see the difference in these two graphs and why this one is not a function and how this one is a function. Okay, that's how we can just tell if we're already given the graph of a function. Now, this is lesson 1, activity 1. We are going to continue talking about functions. So if that's still like, whoa, that's kind of a lot to take in, don't worry. Okay, this is our last activity and then we are going to be done. So it says 1.2, 3 days in a row, a dog owner tied his dog's 5-foot leash, underline his 5-foot leash, to a post outside of a store while he ran in the store to get a drink. Each time the owner returned within minutes. Okay, the dog movements each day is described here. So we've got day 1, 2, and 3. So for the first one, the dog walked around the entire time while waiting for its owner. Next one, the dog walked around for the first minute and then laid down until its owner returned. And then on this last one, it says the dog tried to follow its owner into the store, but was stopped by the leash. Then it started walking around the post in one direction and it kept walking until its leash was completely wound up around the post. And then it stayed there until its owner returned. Now, 2 things that are important about this information. Each day, the dog was 1.5 feet away from the post when the owner left. Each day, 60 seconds after the owner left, the dog was 4 feet from the post. So it says your teacher will assign one of the days for you to analyze. It wants you to sketch a graph that could represent the dog's distance from the post in feet as a function of time in seconds since the owner left. Okay, so before you get into sketching it, I want you to take a look at this little statement that they gave you over here. Okay, the wording that they gave you is very important to understand how to read it. Okay, because this is how, for the rest of the unit, they're going to describe a function. Okay, they're going to describe it with this particular wording. They're going to give you a certain variable. In this case, we have distance. And they're going to say, as a function of, and then they're going to give you another variable, time, in this case. Okay, so anytime you're going to be given a description of a function, they're going to tell you something. So write this down over here. Something as a function of something else. All right, and every single time it's written like this first variable that they give you is always going to be your y value. Always, no matter what. So in this case, what is our y value?
Distance.
What's the first variable they give us? I think someone just said it. I just was talking.
Distance from the post in feet.
Distance from the post in feet. All right. So if that first variable is always going to be our y value, then that second variable as a function of our x. So the x in this case is what?
Time in second.
Time the owner was gone.
Yep. Time. So we're going to have distance as a function of time. Okay, so we can already see those values represented in our graph. We can see time is on our X, and we can see that distance from the post is on our Y value. But sometimes they're not going to give you the graph. They're not going to give you any of that information, and you're just going to have to know based off of this wording which one's your X value and which one's your Y value. Okay, so that is how they will always, a description of a function will always be written as a function of something as a function of something else. All right, so now we're going to take time and we're going to sketch us a graph. Okay, I'm going to do one of them with you just so you have some sort of idea of what you're supposed to do. So looking at those 3 days, which one of these do you want me to graph?
Let's do 2.
Day 2. Okay, so I'm going to graph day 2. Now, what I want y'all to do is I want you to take all your pencils and I want you to set them down for a second because there's only one graph here. So because there's only one graph, y'all can't draw this one. Y'all are going to draw your own in a second. Okay, so just put your pencil down for now and pay attention. So first things first, it says sketch a graph that could represent a dog's distance from the post in feet as a function of time since the owner left. Okay, I'm going to do day 2, which says the dog walked around for the first minute and then laid down until its owner returned. Now, before I even get started on that, I want to remember these 2 important details that they told us down here. One is that each day the dog was 1.5 feet away from the post when the owner left. Okay, so I'm going to go ahead and graph those points. So 0 seconds since the owner left, the dog was 1.5 feet away. Do y'all see how I did that? The distance from the post was 1.5 feet. It's 0 seconds because the owner just left. Next, each day, 60 seconds after the owner left, the dog was 4 feet from the post. So I'm going to go to 60 seconds and the dog was 4 feet. All right, so even on whatever day you choose, day 1 or day 3, here in a second, you will have to have those 2 points. Okay, because that happened each day. Moving on, it says the dog walked around for the first minute. Okay, do we know how far away he was from the post when he walked away?
No.
No. All we know is that it is a function. Therefore, each input can only have one output. Okay, so I can just kind of make it like this. Just start here. Okay, so the dog started walking. Can't. Oh my gosh. Hold on, my computer is. So the dog starts walking. He's walking, he's walking, he's walking. He's kind of walking back. He has to go through that point at 4 minutes. Okay, and now
You mean at 1 minute?
sorry, my computer keeps freezing. And I went too far here. Okay, so he's walking around the whole time before, but what does he do after 1 minute? What does it say he did after 1 minute?
Lay down.
Laid down until the owner returns. So as soon as that 1 minute starts, which is 60 seconds, he's not moving anymore. He just lays down until the owner gets back. So he's going to be that same distance away, but the time is still going to continue forward. Right?
Yeah.
Okay. So the only thing we have to make sure of is that it passes the vertical line test. So I can just get my vertical line, which y'all could just use your pencil. Get my vertical line and just go across it Yep, passes my vertical line test. I'm good to go. Okay, so I'm going to give y'all a little bit of time. I want y'all to, you can choose either day 1 or day 3, whichever one you want. Just because day 3 has more information does not mean it's any harder than the other ones. Okay, so go ahead and take a second. I'm going to give y'all about a minute to try that, and then we will talk about it together. Okay, let's look at it. All right, so for the day 1, now yours may not look exactly like this, so don't erase it if you got something slightly different. But this says the dog walked around the entire time while waiting for its owner. Okay, so the only thing remember to do is make sure that it stays a function. Okay, so the owner took off, the dog's walking around. Okay, so time's moving forward, we're getting closer, we're getting further from the post. We're going to kind of get closer to the post. Oh, but we have to go through my point. Okay, the dog's walking around, time's passing, he's just kind of walking, and then we're walking. All right, now I got to check. Does it pass the vertical line test? Yep, no 2 points at the same. No 2 outputs at the same input. It passes my vertical line test. Now, is this the only way my graph can look for this? No, it doesn't have to be like this. You could have easily said the dog walked around the entire time like this. Okay, he's still moving around the whole time. Time is still passing. Now, something you could not have done is you could not have gone like this. Why is this one wrong? This one's wrong for multiple reasons. Someone unmute yourself and tell me why this is wrong.
Because the line's not going through the coordinate at all. But
Okay, there's one reason. Okay, we completely skipped this coordinate here, which said that each day the dog was 4 feet from the post at 60 seconds. Okay, there's one reason why it's wrong. What else? Is it a function? Right there?
no.
No, look. It's touching my line right here, right there, and right there. So that cannot be a function because it has, for that one input, it's saying that at 10 seconds, the dog was 2 feet, 3.5, and almost 4 feet from the post. Can the dog be at multiple spots at the exact same
No.
time? No. Okay, so that's why we have to make it a function, because the dog can't be at multiple places at the same time. All right, and then one last reason you may have forgotten about is that it cannot go above the 5. Why can it not go above the 5?
Because the leash is
Because the leash is only 5 feet long. Told us that right up here at the beginning. Okay, so your line couldn't have gone above that, because once the dog gets there, the leash is going to catch it, and it's not gonna let him go past that point. Okay, so yeah. All right, and then the last one we have is day 3. So let's go to day 3. It says the dog tried to follow its owner into the store but was stopped by the leash. Okay, so the owner started going inside, but the dog started following him. Okay, and he got stopped by the leash. Does that mean he was getting closer to the post or further from the post?
closer to the post.
He was getting further from the post, so my line's going to be going up. Okay, but it can't go past what?
My boy
Why can it not go past?
Lake.
It can't go past that 5 feet. Alex, focus. All right. So then he realizes he gets stopped by the leash. So then it says he started walking around the post in one direction, and it kept walking until its leash was completely wound up around the post. All right, I want you to think about that. The dog starts walking around and around the post. What's happening to his leash? What happens to the dog's leash the more it walks around the
It gets
pole?
tangled up more.
It gets tangled up and it gets shorter, okay? So what's my line going to start doing? What's this line on my graph going to start doing if my leash is getting shorter now?
Decrease.
It's going to start decreasing. It's going to go down, and it has to go through that point, and then it's going to go down and down and down and down and down until he doesn't have any more room, and he just stays there until his owner gets back. Okay, so if your line looks something like this, then you did it correct. If it doesn't look something like, it obviously doesn't have to be the exact same, but pretty similar to this, it needs to increase and then decrease, and then kind of level off there. And then because it is a function, you need to check and see, does it pass my vertical line test? Well, let's see. Get my pencil, get my vertical line. Oh, snap. Oh my gosh. Go across my graph, and yes, it passes the vertical line test, so therefore it is a function. Okay, so that brings us back to this little description that we posted earlier. Okay, hopefully you have this written somewhere on your paper. So why does it make sense that it was written this way? And we kind of already talked about it a little bit. Why does it make sense that we wrote it as distance as a function of time and not the other way around? Why did X have to be our time? Why did time have to be our X and distance have to be our Y? What did we say earlier about the dog's position at a given
Its
time?
leash is only like 5 foot long, so it had like a limited distance.
Okay, yeah. But what does that tell? But what does that mean about our time? What do we know about where the dog is positioned at any given time? Remember my non-example of a function, the one I said, why is this one wrong? Okay, look at this example that I'm about to draw. Okay, we go here, we go here, and then we go there, and then we go there. Okay, we know that this does not pass the vertical line test because at 20 seconds, it's saying the dog is 2 feet from the post, 4 feet from the post, and 5 feet from the post. Okay, so why is that wrong? So 20 seconds after the owner left, can the dog be both 2 feet and 4 feet away from the post?
No, you can't be like that far at the same time.
You can't be 2 places at the same time. Okay, so that is why time has to be our X and distance has to be our Y value, because if it was the opposite way, if it said time as a function of distance, then that would say that he could be at 2 places at the same time, which isn't true. All right, and then one last little thing about the vocab that y'all need to know before we move on is that this value right here is considered the output. Well, we already knew that. We know that y is our output, x is our input. We said that earlier. But what the book is going to start using in this unit is that y is our dependent, and you're probably used to this in science class. And x is your independent. And a way you can remember that is they both start with n for the x value, okay? So a question may be like, what is the independent variable when distance is a function of time? So what's the independent variable?
X.
The x, the time. In this particular case, it's different in every question. Okay, so those are some vocab words. So somewhere on your paper, you need to have this written down. Okay, these go together and all of these go together. Someone was about to say something, what? All right, that is all I'm going to do for today.